Hello class, this is Mr. Lehman. I want to talk to you about the rest of lesson 5 here. This is all about kinetic theory of gases and temperature. Very important stuff, which will lead us into the gas laws in the next couple lessons. So kinetic theory of gases is talking about how do the particles, how do the molecules and atoms that make up a gas sample, how do they move? If you look at them on an atomic level, if you look at them at a molecular level, and we're able to see the particles moving around, here's what we would see. So KTG, Kinetic Theory of Gases, abbreviated. First statement, all gas particles are in constant motion. And so if you look at the atoms making up a gas, they're constantly moving. They're not stationary. They're constantly moving. How are they moving? Statement 2, they're moving randomly. You cannot predict which direction a molecule is going to move. They're moving in a straight path, and so they're constantly just moving very quickly, very rapidly in a straight line. There's lots and lots of collisions. We'll talk about that in the next slide. The gas particles, gas is mostly empty space, and so the gas particles are very small in relation to the size of the gas, and also they're very far apart from each other compared to a solid and a liquid. That's why we can wave our hand right through a gas and not feel it. That's why we can fly an airplane through a gas without minimal, effect. Try to fly an airplane through a solid, you're in trouble because the atoms are packed tightly together. Gas particles are constantly, because they're randomly moving around. Imagine like a pool table, and you're breaking the pool table, you're breaking the rack, and the balls are just moving randomly in all directions. They're going to collide with each other. They're going to collide with the sides of their container, like the edge of the pool table, or if we're talking about a container, talking about a bottle. The collisions are elastic, so when they collide with each other, they're not going to lose any energy. So over time, these collisions will not result in any gaining of energy or losing of energy, but all the energy will be conserved in the collisions. And finally, within a given sample, at a given temperature, we're going to have particles that are moving slowly, a lot of particles moving at a medium pace, and then a few particles moving at a very rapid rate. So the particles within a sample of gas have different speeds. This brings us to temperature. What is temperature? Temperature is measured using a thermometer. Temperature measures the average kinetic energy, not just the speed, the average kinetic energy. Kinetic meaning moving, the average energy of movement or motion of the atoms in a sample. So if you look at the formula for kinetic energy, the most important part is how fast they're moving, velocity. Velocity is speed, and we square the speed, so that has double importance. But also, we have mass. So how big the atoms are also influence how fast they'll be moving at a given speed. If we had two gases at room temperature, one is hydrogen, the lightest, the lowest mass of all of our gases, and the other one's radon, a very heavy gas. The one with the lighter mass at a given temperature is going to be moving a lot faster than the one with the heavier mass. And so it's like if two cars had the same engine, if you got a little car, a really lightweight car that has an engine, and you had the same engine and you put it maybe in a bigger truck, a heavier truck, and you tell them to floor it, the smaller car, because it has less mass, is going to go a lot faster, a lot quicker than the heavier truck. Even though it has the same energy, the same engine, it has more mass and it would go slower. So I hope this helps. Have a great day.